So looking ahead to our final exam, I am currently planning on administering the final exam through HackerRank, okay? And so here is, so you can type in HackerRank, and it's a place for you to, you can, here it says for developers, this is gonna be you, right? So there's companies use HackerRank to start to kind of assess people's coding abilities, and then people who code will sign up as a developer. And let's see, can I sign in here? Okay, so I think, okay. Oh wait, is this, maybe this is not me. Okay. Okay, so all right, I don't know. So anyway, you can create an account, log in, and there's different things. So there's, Python is one of the things you can do, and you can sign in, and you solve a challenge, and basically you'll you write your code, and then you can run it, and it will show you kind of the output, and it's okay, well that's good, and then you submit it, and then you'll get evaluated, right? And you get a point. Okay, great. Okay, next challenge. Okay, n is if n is odd, print weird. If n is even and in the inclusive range of 2 to 5, print not weird. If n, okay, so anyway, you have all of these things, right? And I guess you would do something like this, right? So you do n% 2 equals 0, and weird or something, right? Like that. Oh, if n is odd, okay, or something, right? Okay, so you run this. Is obviously not going to work. So if I try to run this, it will say this gave me the wrong answer. Test case 0, it came out correct, but then 24 should have done something, and it didn't do that. So anyway, you can start doing this, and this will give you some practice here. Okay. Companies, if you apply for jobs and internships, some companies will use HackerRank as a way to kind of test your things. Okay. And so I have signed up with an academic account. And so anyway, I think I can log in on this side. I got to figure this out. But anyway, okay. So you'll get I guess. So I'll set it up, and I'll send you an invite, and then you'll all be required to take it. This one, as the first one, will be a homework assignment, okay? And as far as the homework assignment goes, it'll either be a you did it or you did not do it type of thing, okay? So I'm not gonna assess you on whether it's correct or not. Obviously, you should try to get it correct, but then. And I'll take a look at the results there to kind of gauge, whether this is a system that works, and if I feel comfortable moving forward with it, then we'll use it for the final exam. But I want everybody, so I'm going to send you kind of a practice exam, practice problems, practice exam, and then. That will be your homework. You'll just get credit for attempting, and you'll get some kind of grade. Or HackerRank will give you your grade, and then, but yeah, we'll just say this initial one will just be based on completeness, and then if it works, we'll go forward with the final exam. Okay, I don't know if you guys have questions about that, but I'll send that out, and you guys can take a look at that. All right, so today we will take a look at Pandas. Pandas is the package that we frequently use for working with data in Python. Python's native base Python does not have a data structure for a data frame. So we've seen things like lists and dictionaries, and these are excellent. But if you want to create a data frame, it's not going to work. Okay, and Python also does not have a structure like the atomic array. So Numpy creates arrays, and every inside the array, all the values have to be of the same type. And in Pandas, you have the data frame where you have columns. Each column is an array. Okay, and the column is the array where each column has to have the same data type, but you can kind of mix different data types together in different columns. Okay, so similar to the data frame in R. And so to get this to work in Python, you're going to do import numpy as np and import pandas as pd, and that's just the convention, so everybody can kind of follow along with what you have, right? So what you have, the basic data structure is the series, and a data frame is created by kind of combining series together, okay? And a series consists of basically a numpy array attached to an index, okay? The index argument is optional, but all series will have an index. If you don't provide the index, Pandas will create an index for you, all right? And this is a little bit of a different design philosophy than the data frame in R. In R, you don't have, each of the columns are vectors, but you don't have an index associated with the elements there. Okay, so here's a series. I just take a list of numbers 0.25, 0.5, 0.751, and I say make a series out of it. So I do pd.series and I throw that in there, and this is what it comes out. Okay, and if I say what is the type of this thing, it says it is a pandas series, basically. Okay, and so we can see that we didn't specify an index, so pandas automatically created just a zero indexed index for us. Okay, if you call data, if you say print data, it looks like this, and then if you just type in data, it also gets produced like this. Okay. Okay, so the series is printed out in a table form, and the type is a pandas series. Here, you can get the attribute values. Okay, the attribute values from the series. Okay, so here's the series data, and if you do data.values, this is a numpy array. Okay, the type on data.values is a numpy array full of floats, right? Okay, the values attribute is a numpy array. Here, we can ask for data.index. Okay, the index, you get back an index object. This is a range index, indicating, much like the range object, is has a start and stop and a step. But here it's a pandas index. Okay, so you got pandas index, and it says this is a range index. And there's different kinds of indices, but by default, if you don't specify an index, it's going to create an index for you, and it will be that. All right. Okay, so you can subset series and pandas just like other Python objects. So if you say data index 1, and it gives you back this value 0.5, this is just the value itself. It's a floating point number. Okay, it simplifies it. Okay, whereas if you pick multiple values. So if I slice it and I say slice from 1 to 3, okay, it's going to give me back 2 elements here. The first and the, not the first, index 1 and index 2, which is the second and third elements in the series. And this comes back, when you slice it, it comes back as a series, right? So if you subset it, so it just returns one value, it will return it as, whatever type that is, whether it's a float or an integer or a Boolean value or whatever it might be. But if you, subset multiple values, you get back a series, okay? You can also subset using fancy indexing, right? So you can say subset the data using this, using an array, okay? So you give it an array with the values 1, 0, 2, and it pulls out index 1, index 0, and index 2 in that order. All right. If you want, okay, you can specify the index yourself, right? So here I'm creating the same series, except rather than using the default index, which is going to be 0, 1, 2, 3, I can say for the index, use this these values A, B, C, and D. Okay, and so so this is what we get. We get a series, and the index values are A, B, C, D, and it's exactly that. Okay, so data.values is still a Numpy array, and data.index is now a Pandas index object, okay, with the values A, B, C, D, okay? The data type, when you have strings here, it doesn't say data type string, okay? It comes back data type object. And the reason for, they call it object is because it's basically strings, but it also allows for nans to appear for missing values, right? So technically, nan is always a floating type, is a floating point number, okay? Just representing not a number, nan. And so technically you can't really mix that in with strings. And so Pandas kind of created kind of a superset of strings, which includes strings and nans, okay? So nan, so pretty much if you have string data, it's gonna get classified as object in Pandas. All right, so when you have an index specified, A, B, C, D, you can still select from the series using the index position. So you can say, what is the value at index position 1, okay? And that gives you 0.5, right? You can also subset using the index name. So you can say, what is the value at index A? So index A is at 0.25, okay? So you can slice using index behavior, index position. So you can say slice from position 0 to 2, and that gives you that, A and B. So from 0 to 2, that gives us there. You can also slice from using the index names, okay? When you slice using index names though, okay, one thing to note is that it'll say, start at A, go up to C, and it will include the value at C, okay? So whereas 0 to :2 will slice starting at index 0, but goes up to, but does not include the value at position 2, okay? So the slicing behavior, this is in line with everything else at, everything else in kind of Python. But here, if you're slicing using index names, it's going to include the last value. So if you say slice up through index name C, it's going to include C here. So just something to keep in mind. All right, so here you can create a series from a Python dictionary, okay? So I've created a dictionary. This is from some silly show, Riverdale. I don't. It's like years old now, but anyway, okay. So here we the question. Is that slice dependent on the alphabetical order or just the order you input the index? So yeah, so the slice goes in the index order. The index order happens to be alphabetical, but let's say this was C, X, J, and K. You can slice from C to J, right? So so it's just in the order of the just in the order of the indexes. Okay, so it's not, there's no inherent alphabeticalness to these index names. It's just it's dependent on the index order. So here, like I've created the index, okay, is Archie, Betty, Veronica, Jughead, Cheryl. You can slice from Betty through Jughead, okay? And that's not going to be in alphabetical order, right? Okay, so here we have the dictionary. We say make a series out of the dictionary, okay? And the series gets alphabetized by its index. This is not true. I don't know why I wrote that there. Okay. Okay, so here's the index, and sorry, I gotta fix that. Okay. Okay, and here are the values. Okay, the values, the index, the values. Okay, and this is a dictionary, and this is a series. Okay, so when you created a series. Okay, so and here is another series that so I don't, okay, I don't know, something must have changed here. Okay, so so we create the series, and it goes in like this. Okay, so I get so here I put these in A, B, V, J, C. Okay, and this is A, J, B, V, C. Okay, so the series get defined in different orders. Okay, so this goes Archie, Jughead, Betty. And over here, we get Archie, Betty, Veronica for the names here, okay? So what we can do is we can create, how's the series organized if dictionaries are unordered? Yeah, so the dictionary is unordered. The series will often, it'll just kind of create it in this thing. And if the dictionary, I guess, and kind of the default when you kind of just dump it out, however the dictionary gets dumped out into the series is just what how it gets kind of thrown in here. Okay, so when I create these series, they're coming in different orders here. So after I created the series, so once you create the series, it's just like you're dumping out the bag from the dictionary. And when you dump them out into a bag, dumping out the bag, you get just some order of how it gets dumped out, right? And that's just going to be the order of the series at that moment, okay? And so this series and the other series get ordered in different ways. When you create a data frame, however, it will match up the series together, okay? And generally, when you throw them into the data frame, that's when it will attempt to alphabetize your index that comes in, right? So here I've created a data frame by providing a dictionary of series objects, okay? So we're creating a data frame where there's going to be a height column and an actor column, okay? So here, the index is character names, okay? And then this dictionary has the names of the actors that play these characters. Okay, over here we have in the index we have the character names, and the values are these character heights. Okay, and again the series just gets ordered in however the dictionary gets dumped out, right? So you dump out the dictionary, and then we create a series in this order. When we join them together in a data frame, so here I'm creating a data frame, providing a dictionary of basically of column names. Okay, I say height is this series and the actor is this series. Then it joins the index names, and it alphabetizes the index names. Okay, so it matches Archie with height of 71 and actor KJ, and Betty with height 66 and actor Lily here. So so even though it's not in that order, it doesn't go A and B and Archie followed by Betty. It goes Archie, Jughead, Betty. It matches them up, and over here it's in this order, but again it will put them into alphabetical order here by the index when you throw them into a data frame. Okay, and if you ask what is this thing is now a Pandas data frame. Okay, so you throw that into pd.dataframe, and you basically give it the name of the series that you are joining together. So there's some similarity to like the way you create a data frame in R. In R, you kind of use data.frame, and then you give it like variable one name equals the vector, comma, variable second name equals some vector. And here you say data frame, and you give it the variable name colon the series, the variable name colon the series. Right. You can also create a data frame with a dictionary or a list of dictionaries. Okay, so here I've got A has value 0, B has value 0, A has value 1, B has value 2, A has value 2, and B has value 5. So I've got a list of dictionaries, okay? And so each of these dictionaries need to have the same set of kind of keys here. And so here's my list of dictionaries. And then I can throw that into a data frame, okay? And here I specified index 1, 2, 3, right? Otherwise it would have just done its normal range index of 0, 1, 2. But here I specified an index, I give it a list, and it matches these up. Okay, so I have a list of dictionaries, and it goes, it lines up, okay? Here I have a list of dictionaries, A and B, but this dictionary has A and C. And so, so when I create a data frame out of this dictionary, we're going to get some nans. Okay, so it creates it matches up the A's. It finds the 0, 1, 2. For the B's, it finds the 0 and the 2, but it finds nothing in this observation for B, so it throws in a nan. And then for C, it has nothing for these two, so you get nans, and then you get a 5.0 for this one. Okay, this is in Jupyter when you type in a data frame and you don't say print, it prints it out in this, the output is this kind of slightly fancy format. I don't know how else to say it. Okay, it's stylized format. Whereas if you use print on a data frame, it comes out in this kind of more monospaced font. Okay. Whereas here, I didn't call print on it. I just said, what is the data frame? And it outputs like this in Jupyter. Okay, you can also give it a dictionary with list values here. Okay, and basically the keys here form the column names, and the lists the values for each dictionary item is a list of values. Okay, so here's the dictionary, and we can say make a data frame out of this, and it does that. Okay, so we get 1, 2, 3 showing up in column A, X, Y, Z showing up in column B. Okay, and again, I didn't specify an index, so it defaults to the range index 0, 1, 2. Okay, you can also take a Numpy array. Okay, so here I just say give me 10 random digits arranged in a 5x2 matrix. Okay, so this is a 5x2 Numpy array, and we can say make a data frame out of this. Okay, so we can say data frame with the data here, this 5x2. We're going to give it the column names X and Y, and then the index we specify. You know, again, you don't have to, but here we go. Okay, and this time I called print on it, and so you get the monospaced fonts here. So these are all different ways that that you can kind of make Pandas data frames. Although probably most common way of getting your data frame is you'll have a CSV file and you'll read it in as a data frame. Okay, but again, if you kind of just need to assemble a data frame quickly, you've got multiple options to do it. All right, so you can subset a data frame, right? So here's our current data frame. We have 2 columns, and then we have row names, or this is what we call the index. Okay, so the index has the character names here. Okay, and we have columns height and columns of basically actor names. All right, so if you ask for the keys of a data frame, it gives you basically the column names. Okay, so the keys of a data frame are the names of the columns. Okay, so we got height and actor. The column names also form an index. Okay, so the row names form an index. Okay, the column names is also an index object. Okay, it's we often don't think of this, but it gets treated as an index object as well. Okay, but and the columns are pretty much just the column headings. Okay, so that's going to be the data frame keys. Okay, and note the notation is you say the name of the data frame dot. So it's this is technically, I guess, a method or an attribute associated with the data frame. So you do data frame dot keys with parentheses, and it prints out the index there. Okay, so here you can extract a column using bracket notation. So you can say Riverdale, and then you give it in quotes the name of the column that you want, and you get this. Okay. You can also use dot notation, and you can give it the name of the column. Right. So you can do Riverdale dot actor, and it will pull out the exact same thing. These two things are identical. Okay. So for because of this notation, it's recommended that your column names don't have spaces in them. If you want something that looks like a space, use an underscore. That's kind of the general recommendation for Pandas. Column names shouldn't have spaces. Okay. And then and so once you have this, you can also this is a series, and so you can treat it like a series, and you can subset from there also. So you can do Riverdale.actor. What's at index position 1? That's going to be Lily. You can also subset using the index name. Okay, and you can say, okay, who's the actor that plays Jughead, right? And you get this. Okay. All right. You can take a transpose of a data frame, and it's going to basically swap the indexes. All right, these are still so it's a little strange to think about this because we've emphasized how so these are still series. Each column is still a series, and it's still a Numpy array, and you wonder, well, how can you have different data types in a single Numpy array? All right, So NumPy actually does allow for different data types in an array, but you have to specify the structure. So you must say, in this NumPy array, we're going to have mixed data types, but the first element will always be an integer and the second element will always be a string, okay? And if you tell NumPy that, then NumPy will allow you to mix data types within an array, okay? In general, NumPy arrays all are the same data type, but you can create what's called a structured NumPy array, and you can say, for this array, the first element will always be an integer, and the second element will always be a string, and so NumPy will keep track of that and ensure it, and it'll throw an error if you try to break that. Okay, so kind of going back to this thing. Whoops. Here's our data frame. You can say, all right, I want this row that says Jughead, okay, where it has height 72 after Cole. You can say, I want this row, okay. So if you do that, you can use .loc, okay, .location, okay. So you say Riverdale .location, and you specify it, specify an index, and it will pull out the value, okay. Here 72 and Cole. And again, this is a structured NumPy array when you get this out. Okay. So yeah, when you ask what is this, Riverdale.loc Jughead is it's a series, which is going to be a this is a Pandas series. And then if you ask what is the values themselves appear in a structured NumPy array. Okay, it's a NumPy ND array as far as the values go, the 72 and the Cole. Okay. You can extract out a column using .loc. Okay, so .loc, if you only give it one argument, it's going to assume it's kind of the index name for the row. You can also give it the, if you want to pull out a column, you can use colon for the where it's expecting the row value, and this is going to say, give me all the rows, but give me just the column associated with height. All right, so you can do that. And this is kind of like subsetting in R for a data frame. Okay, but here we're using .loc, all the rows and the column height. Okay, and again, it's still a series and it's still an ND array. Okay. And then if you want, you can also specify both the index and the column, and it extracts out that one value. Here, the value is 71, so that's what you have there. Oh, sorry. You can also use iloc. Okay, iloc uses index location. Okay, iloc is basically using a zero-based index location. Sorry. So here, Archie would get iloc 0, iloc 1, 2, and Jughead is iloc 3. So you can say iloc 3. iLocation, index location, and we get 72 and Cole here. All right, and so that's what you can do. You get iloc here. Sorry, give me a moment. Okay, and so here, if I do iloc 0, 1, all right, this is basically a pair of coordinates for selecting a value out of there. So this will be row index 0, column index 1, which will correspond to the actor name for Archie. Okay, and that's what we have there. Okay, and then lastly, we'll take a look at just importing a data frame or by importing a CSV file, right? And so, see here, there's a CSV file from Data Camp that contains Titanic information, all right? And so, so basically you just do pandas.read_CSV, and then you give it the file location. So the file location can be, you know, if the file exists in your home directory or your working directory, you can just give it the name of the file. But you can also give it the name of a web address. So here's the web address for this CSV file. You can load that up here, and it gets loaded. And here we'll just ask for the head of the data frame. And again, Jupyter stylizes it. Okay. And so, so when we did this, I didn't specify an index or anything. And so, so it automatically gives us an index, range index, 0, 1, 2, 3, 4, all the way up to the end. And passenger ID, and then it includes information on whether this passenger survived or died during the sinking of the Titanic, and all of this stuff here. Did I just talk about Titanic? Or was that like a different class? I don't remember. Okay. Oh, it was a different class when I was talking about projecting into 3D. Okay. All right. Titanic. So a data frame, you can will have attributes like the shape. So we have 891 rows, 11 columns. And if you,
it's not on the table. It's not on the table.
All right, we've got, you can ask for the column names. All right, again, this will give you the index object containing the names of the columns. All right, and so so we've got the names of the columns there. The index itself is a range index. Okay, with 891 rows there. And then you can also ask for .info. This is kind of like your structure, str function in R. This will kind of list off the name of the columns, you know, the index number for the column, and then how many values are in there, how many values that are non-null, okay? And then what's the data type, right? And so things that are integers will be expressed as integers. Things that are strings, okay, will show up as object to kind of indicate that you can, and again, notice as far as object goes, you know, like cabin, it says 204 non-null, okay, which means we have a lot of missing values, okay? And so those will show up as nans here. So, so for example, cabin will have string values along with nan values, and so these show up as data type object, okay? Because normally nan is a float object, strictly. All right, there's also describe, okay? You can do titanic.describe, and what it will do is for everything that is numeric, okay, so everything that's not an object, okay, so you're not gonna see sex, ticket, class, cabin, or embarked in here, but you'll see the other 7 columns, okay? It will do a summary table for you, so it'll find the count and the mean, standard deviation, and all sorts of stuff, okay? And so this is the mean of the values that are available that are non-null and things like that, okay? So these are basically the nan-safe calculations. All right, that's all I've got for today. We'll look more at pandas on Wednesday, kind of continuing on here. I've got a few corrections to make in my slides, so let me update those, and we'll end there. Quiz answers. Man, I always forget about my quiz. And you know what? Last time, okay. Let's go ahead and say today's quiz answers will be D and E, D and E. So we'll say quiz answers will be dog and elephant, D and E. So we'll do that. Give me a minute to create these quizzes, and so wait a second there, and yeah, I'll do that. Okay. Question about the homework. What is high card and in a row? Okay, so high card is just is basically you know, does the card have a high? Does the hand have a high card? And so it's going to be true for all cases, because right now we just have it as you know, even a 4 of a kind, a hand with 4 of a kind will also be true for, you know, 3 of a kind, 2 pair, pair, and high card. So high card is going to return true. In a row is a helper function that hasn't been defined, but it's something that you could use. You don't have to. Yeah, you don't have to use in a row. Okay, it's a function that that you can define that could help you in finding a straight, but it's not required. Okay.
Can I ask
Okay, that's it.
a
The
question?
high card is always true. Yeah, for our for the purposes of this current homework assignment, high card will always be true.
Can I ask a question about like exercise 17.1?
I don't know that one off the top of my
It's
head,
the,
but go ahead with your
It's
question.
the one where you have to change the attributes of time to be like a single. Okay, so it's the one where you want us to modify the methods with like time. So it's like where you only have one attribute, self.second. I'm just kind of confused on that one, like what you're asking. I'm just kind of confused. That's really all. Like
Okay,
what
so
you
right
want us to do.
now, I think the time as it exists, you store the hours, the minutes, and the seconds. Okay, and you know, what if, you know, and this is just the convention that we're used to, right? I say, you know, it's 2:50 p.m., or I could say, you know, it's 14:50, and you know, whatever. What if another perfectly valid way of telling time is how many seconds have elapsed in the day? So if we say the day started at midnight, okay, 1 minute in, we would say, you know, the time is 60 seconds. 1 hour in, we would say the time is 3,600. At 2 a.m., we'd say the time is 7,200, right? And that would go all the way up until 11:59:59, which I don't know, whatever it is, okay? And you could tell time. And now that would be inconvenient. We're not used to it, but it's also a perfectly valid way of telling time. And so so that's what the homework problem is asking, is saying, you know, what if this time object that we're creating doesn't store 3 attributes, hour, minute, seconds, but it just stores the number of seconds that have passed since midnight. And it's another perfectly valid way of recording the time. And then it would just be a matter of taking that single value, and then as far as presenting it in a way that's being understood, is you'd break it up into the hours, minutes, and seconds portions. Does that kind of make sense?
Yeah. So do each of these like functions in the class need to be changed, or is it just the ones that like?
So you would have to modify the methods in the class a little bit, but as far as how someone interacts with the class, that should remain unchanged. So you would have to make a few modifications so that the storage of the class, there's only going to be self.seconds. Yeah.
Okay. Thank you.
All right. Have a good day, you guys. We'll see you on Wednesday. And again, give me a minute to create this quiz that has the answers D and E.